My intention is twofold: to explain the concept of information and to explain that saying reality is a simulation is incorrect. The nice way of saying there is a problem is saying information is a homonym. It has more than one meaning. We have a definition, but we also use the word in other contexts. For instance, when we say that a hard disk has information on it. We could also say the word is often misused. The hard disk really has no information on it. Some of its structure can be interpreted on paper as information. The computer does not hold or use information. It just manipulates elementary particles, photons and electrons. Let us begin explaining the concept of information. There exist several different mathematical definitions, all aiming in the same direction. Here, Claude Shannon's is used. Information is a number derived from the probabilities of particular events occurring from a complete domain of events. Further on, the definition will be refined, but this suffices for now. Information is a number or string of numbers, a paper concept. On paper, it is realized by ink. In our minds, it is realized by neural activation patterns. Anything can be described by information, or more refined, anything real from a human perspective can be interpreted with the concept of information. Or even more refined, anything real can be recorded or reconstructed as a finite set of finitely many real things, a string of symbols, that can be interpreted on paper as information. A machine, a reconstructor, shapes real stuff into real stuff. Something new and real can be created using a machine and a string of real symbols. A digital recording of music is a collection of real phenomena in the computer or on compact disc. On paper, the recording represents information. Only on paper are the bits. Only on paper are the zeros and ones. Information, consisting of numbers, is always discrete. This comes from making the distinction between 0 and 1. I made a video on that. The machine shapes real stuff into real stuff. Real stuff is never made of numbers. It is never made of information. The digital movie can be created by a combination of a hard disk, a computing device, and a screen, converting electromagnetic phenomena into other electromagnetic phenomena, from magnetic polarization to radiating color patterns from a screen. In the case of music, the machine or reconstructor is, for instance, a compact disc player, plus amplifier plus speaker, converting electromagnetic phenomena into moving air molecules, from plastic holes to vibrating membrane. The hard disk and compact disc are real implementations of strings of bits on paper. Quite complicated, therefore lots of possibilities for misunderstanding. Now some more detail on Claude Shannon's definition. This is going to be difficult, but hang on. An example will soon follow. We need a couple of objects, a logarithm function, a chance function, an event, Shannon self-information, and Shannon entropy. The logarithm function and chance function will be assumed familiar. An event is one of all possible events that can happen. For the die from the example, there are 6 different events. Shannon self-information, I, is minus the chance of an event times the log of the chance of that event. minus p event times log p event. Self-information I has a value between 0 and 1 and is the contribution of a single event to the Shannon entropy. Shannon entropy, or information H, is the sum of all self-information, or minus the sum over all events of the chance of a specific event times the log of the chance of that specific event. When all events are equally likely, H is the log of the number of events, because then the number of events is 1 over the chance of an event. A string of information, a string of numbers, is also called information. The more possible outcomes for an event, the higher the number. The Shannon entropy is the amount of information you are giving or you are given when you are told about the outcome of an event. Here is an example about throwing a die and someone telling us the outcome. How much information do we get when we are told the outcome? Two things are important here. How many possible events are there and how likely is each event? There are 6 possible equally likely states or events for an honest die. A natural measure for the amount of information that comes to mind is the number of symbols needed to communicate the message. This number is dependent on what number system we choose. Will it be our familiar decimal system, perhaps a binary system, or some other choice? This natural measure is already quite close to the actual measure for information using a logarithm. A logarithm is a more delicate counter, so to speak, but based on the same intuitive feel. Let's discuss our decimal system and the binary system in this example. In the decimal system, we need at most one symbol or digit to describe 6 events. The events are 1, 2, 3, 4, 5 and 6. All are one digit from a total of 10 possible digits: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. We could actually do with a little less than one digit from a decimal system. The more exact, but in a different way still approximate number, calculated from our formula above, is log 6 to base 10, or 0.778151 digits of information. So not one digit, but 0.778 approximately. In the binary system, we need at most 3 symbols of bits to describe 6 events. The events are 001, 010, 011, 100, 101 and 110. All have 3 symbols from a total of 8 possible 3-bit combinations: 000, 001, 010, 011, 100, 101, 110 and 111. We need a little less than 3 bits from a binary system. The more exact number, calculated from our formula above, is log 6 to base 2, or 2.585 bits of information. So the answer to our initial question, how much information we receive when someone tells us the outcome, is 0.778151 digits, or 2.585 bits. The answer in bits sounds familiar in this age of computers. Summarizing in different words, we can roughly count the symbols in the number that indicates the amount of possible states to indicate the information value of one state. For the outcome of a die, the number would be 1 decimal digit or 3 binary digits. In physics, Boltzmann's famous formula for entropy has the same structure as the Shannon entropy. Entropy S is Kb natural log of W, where Kb is Boltzmann's constant and W is the possible number of microstates of the system of particles. Implicit is the assumption that every microstate has an equal chance of occurring. Boltzmann's constant relates the average kinetic energy of particles in a gas to the temperature of the gas. In this case, we count the number symbols that indicate the amount of states by the natural logarithm to base e, Euler's number, approximately 2.718, instead of base 2 or base 10. The unit of counting to base e is a net, for a natural unit of information. Like we have bit and digit, we now also have net. Again, in other words, given the perceived structure of the system, in this case moving particles in a volume, an ordering mechanism of states is the basis for putting a number to chaos or complexity. The amount of information of a system is directly coupled to the perceived structure of the system. The better we know what the system is made of, the better we can order it into states, and the better and more detailed we can describe it in terms of information. Back to we live in a simulation. Reality is a simulation suggests that a machine outside reality exists that somehow shapes the bits of information into reality. Where did that come from? The alternative is that the information, which is by definition an assembly of numbers, is reality, which begs the question, how do numbers then change by themselves? I believe both alternatives can be considered nonsense. It's just a bit sloppy use of the word information that leads to this speculation. But remember two things. We can describe nonsense or fantasies like elves and gnomes and the Matrix using information, and everything can be sort of described by bits on paper. However, bits are no building blocks, no machinery, no material for anything but strings of bits on paper.